Okay, our objective today in 11.2 day 1, we're to find the surface area of a prism and a cylinder. It's the cylinder we're going to do tomorrow. We're going to do some pre-notes for it today. Okay, find the surface area of a three-dimensional figure by finding the sum of the areas of all the surfaces of the figure. Prism. A prism is a three-dimensional shape that has two bases that are identical. Now, if it's rectangular, you have three sets of bases that are identical that you can call a base. But if it's not a rectangle or a square, the bases are the thing that ain't no rectangle. Okay? People go, how do you know, Bloom? Because if it's not a rectangle, it's the base because they name it by it. So if I'm looking over here and I got a pentagonal prism, well, the base is a pentagon right there because the lateral area, the lateral sides, the soup can, thinking about that, the soup can is rectangles. Okay, it's making up rectangles. If I'm looking at this one, the triangular prism, I've got a triangle as a base. So now, keep in mind, when I'm talking about base, we're going to use the word big B or the phrase big B, okay? Maybe if I remember to do that every time. But what it comes down to is you're going to change big B's formula. Because if it's a pentagon, you're going to go 1/2 ANS. If it's a triangle that is equilateral, you can go 1/4 x squared, the square root of 3. If it's a triangle that's right, you're going to go base times height divided by 2. You have studied those shapes. Big B represents the shape of the base, and all the stuff we did in chapter 10, all the stuff we did in chapter 6 for learning about shapes, and we did triangles again in chapter 5, is big B. You identify the shape, you put in the correct formula, and we have big B's area. So now, with the rest, we're going to talk about generally what would we do to find surface area. So the bases of a polyhedron are parallel polygons that are congruent. So I talked about the bases. These are parallel to each other, okay, when we're talking about these, when we're looking at our prisms. And now, if I can get this down, our lateral faces are faces that ain't bases, okay? So if they're not rectangular, they're the lateral face. If you have bases that are square or rectangles, you decide which ones are going to be the base, and the ones that aren't the bases are the lateral faces, okay? Now, altitude of a prism is the perpendicular segment that joins the planes of the bases. That's also height. Okay, now the height of a prism is the length of the altitude. Hey, way to go. Those are the same, except when we're talking about right prisms and oblique prisms. A right prism is the side. The side is in perpendicular to the base. Lateral faces are rectangles, and lateral edge is an altitude. So we're talking about this being a right angle. That's going up the side, that's the height. Or the separation between the bases. Now, here's the thing. You guys aren't in elementary school anymore, so now I can actually have a prism sideways. And you've got to know that the distance between the two bases is actually the height. That height might be a horizontal measurement in that shape when it's sideways, but if I spin it, it can be a vertical shape. So you have to know the distance between bases is height. Now, oblique prism is the sides is not perpendicular. Side is not perpendicular to the base. So we have a line containing the side of the base and the height. So the height of an oblique prism is the distance between the two bases. It's the perpendicular distance. Okay. Some or all the lateral faces are non-rectangular. Okay. They're more like parallelograms. Okay, when we're talking about obliques. Now here's a saving grace for us. In your text, you may assume prisms are right unless stated or pictured otherwise, or in any of our lessons. They are right until stated otherwise, because it's all about a right prism for what we're learning, and regular polygons, okay? Now, going on. Lateral area and surface area. They're two different things. Lateral area, I want you to think in soup can, and I'm going to write that a little bit better. I want you to think soup can label. Okay, the area that is not bases is lateral area. The bases, the faces are lateral faces, I should say, are faces that aren't bases. So once you define what the bases are, the remainder of the shape is lateral area faces. Surface area. Now, surface area, SA, of a prism is the sum of the lateral area and the area of the two bases as we go through. Yeah, we gotta talk about that, yeah. Okay, so now here's the thing. This, when you first do it, is kind of confusing. I'm gonna be honest, there's a lot of jargon when we're talking about this. So when you got a lot of jargon, you got a lot of study that's necessary, okay? Oh, yeah. Okay, so what I want you to do is recognize as we're going through here, there are other ways to find this area. I want you to define the area of each one of these shapes inside this net. Go ahead and do that while I find the test with this other student. Now, just like back in the day, 3 times 4 is 12. 5 times 4 is 20. 5 times 3 is 15. 5 times 4 is 20. 5 times 3 is 15. 3 times 4 is 12. We're going to learn about some shortcuts, okay? Because I could totally add these up, no problem. And, 5 times 4 times 3, 4, 3. Couldn't I just add 4 plus 3 plus 4 plus 3? Isn't that 14? And what's 14 times 5? And some people are thinking it's 70, Bloom, and the other one's 24. But think about how that shortcutted my work. If I just found the area of a base, and there's 2 of them, and I find the perimeter of my base, 4 plus 3 plus 4 plus 3, times the height, the separation of the 2 bases, I have a rectangle because the lateral surface is a rectangle because it's a soup can when we're talking about prisms. Okay, LA will change when we get the pyramids, but today, my soup can label's a rectangle. 94. Are you okay with that? Are there questions? Now I've got some people going, well, is that it? No, we got other things that are going to come in. Remember in chapter 8, section 1, we talked about Pythagorean theorem formally. Whenever I need a perpendicular measurement in something, I get to use it. And people are like, oh, really? I already got it kind of listed here. I don't know what that shape, what that value is, so we're going to talk about it. If I have a shape, let's talk about this shape. I have a shape that's isosceles triangles for bases. Now, I want to point out, this is a prism laying on its side. 50% of you right now would be thinking that that 6 by 12 is its base. It is not, and here's why. A prism has a consistent shape as a base all the way through the figure. Think elevator, platform, the floor of an elevator. What's the shape? It's the same shape as the shaft itself. Okay, think, have you guys seen those little dough injector things you can use to make sugar cookies really fast? You squeeze it and chop it off. It kind of looks like one of those Play-Doh makers. You put the clay in, you press it and oozes out. Okay, the shape that comes out is the same as the base itself. Okay, well, the shape here is a triangle and it goes all the way through. Okay, so my base, and remember the way I defined it, if it's not a rectangular base, it's the shape that isn't a rectangle. Okay, and I'm talking about the prism. This one was a rectangular base over here. That's a rectangular base all the way through, right? But I could have decided that this was my base. And people will, yeah, but all the way through, it's the same shape. Okay, I could have decided that this was my base. And it's the same shape all the way through. Okay, when I get to a rectangular prism, I have all those choices. I have 3 of them. When I have any other shapes other than rectangles, them's are the bases and that's it. Okay, the search is over. So I've got a triangle and that's my base. So now I got to find the information I need to be successful in finding the area of a base. Well, it's not an equilateral triangle, so I must find the height. And able to do that, and it's an isosceles triangle, I'm going to split it in half. Half of 6 is 3. And I'm going to find the height. Well, gosh, you know, that kind of looks like a right triangle, and I could use Pythagorean theorem with it. That's what we're going to do. Pythagorean, no way! I'm finding information I need for a calculation. Pythagorean theorem helps because all the information is there for me to be assisted to do that. So I have 3 as a leg, 5 as the hypotenuse, and I pop them in, I've solved for h. Well, 3 squared is 9, 5 squared is 25. Subtract those, and I should get a 16, and the square root of that is 4. So I got a height of 4. Awesome. My height is 4. Okay, and so that's 4 right there. I just labored to help you with one of the dimensions. I would like you to take the remainder dimensions, the rest of the dimensions, and fill it in on the net I have provided. I'm going to give you one other dimension, that's 6. Fill in the other dimensions on the net I made. And if you haven't yet, please draw that net. Draw that net. After you draw that net, make a determination with the area that's left. Dimensions. The distance between the 2 bases is 12. It says that right there. I have a 5 and a 5, and I've got them made. We talked about a shortcut to help us find the area of the lateral surface. 6 plus 5 plus 5. That's 16 times 12. Okay? That's 160 plus 24, 192. Yeah. No, I lied. 160 plus, oh, it's 6 times 12. Yeah, I don't know what I was thinking. Okay, so we got 16 times 12 is 192. Are you okay with what I did? Remember, that's a shortcut, and it's something the formula we're going to use does for us. Okay, instead of finding 3 different areas and adding them together, I find one area, and that's it. Okay, so it makes it more convenient and efficient as I'm looking for stuff. The next thing, big B, my base. I tailor it. This is a triangle, base times height divided by 2. My base is 6. My height, we found it, it's 4. Okay, divide that by 2. So that's what we're doing. 6 times 4 divided by 2. But why is I have 24 there? What do we got to do special about this? How many of them are there? Say it louder. 2. All right, love it. There's 2 of them here. I have to know there are 2 bases. So the total is 24. Okay? Are you okay with how I got it? I wish you had your face on camera on that one. That would have been funny. Okay. Okay, so we have the necessary pieces of information to come up with the surface area of this shape. Remember, you have access to the formulas for bases. You know that our lateral surface is a rectangle that you find the dimensions of by the separation of the 2 bases, that's its height, and the perimeter of the base. Really, that was the perimeter? The perimeter wraps around the base. And we're going to find that out right now. Lateral area. The lateral area of a right prism is the product of the perimeter P of the base. Now, P is the perimeter of big B. P is the perimeter of big B, the base. And the height of the prism, the separations of the 2 big B's. Take that off. And remember, perimeter times height gives us lateral area. Surface area, okay, lateral area and surface area are related. Lateral area is the area that would be the soup can label, okay? Surface area includes not only the area that soup can label covered, but the bases as well, okay? So again, reread your notes. I cannot emphasize that enough. The vocabulary alone requires you to do that. And then recognizing that the formula is here to help us account for finding all the pieces we need for surface area, okay? The formula is there to help us. So as we're moving on here, I'm going to break the formula down for us. This is going to seem like, oh, really? Is this much work for one problem? Dude, I got better things to do. Once we understand this, these problems go quick. First thing, I've got to find the area of the prism. What's the lateral area of the prism? Okay, as I'm doing this lateral area thing. Lateral area is the area of the label. Okay, the stuff that ain't bases. First of all, the bases are triangles. Bases are triangles. Okay, so we got bases that are triangles. Do I have all the information to find perimeter of that base so I can find perimeter? Because I know the height's 6. Do I have all the information I need to find perimeter of the base? I'm missing a piece, aren't I? Now, not that I'm leading, but did you notice that the piece I'm missing is on the hypotenuse of a right triangle? Wonder what you could use to, oh, I don't know, find a missing side when you're given 2 in a right triangle, and those 2 are legs. We could call one of them A, the other one B. We could use the hypotenuse as C. We're actually doing that, but I've got to find that. And people, where did you bring up that 8-1, man? We've been using Pythagorean theorem since the beginning of time. Okay, or in other words, September. Okay? Keep in mind, once I have a right triangle, or if I can make a right triangle, I can find other pieces of information. That's my critical thinking part, my process as I go through. Do I have all I need? Okay, the first thing I needed was perimeter. Okay, perimeter of my base. I'm just here until I get 5. 5 is this value. Right now I have 3 plus 4 plus 5. 3 plus 4 plus 5 is 12. So P is 12. Okay, I have height H, 6, the separation of my big B's, my 2 bases. Okay, so now I have perimeter times height. My lateral surface, the rectangular wrapper that is my soup can label. It's, I know, a triangular soup can, but none the same. It's a soup can label. Now I got 72. Okay? Questions on how I did it? the next piece of information. What is the area of the base? Big B. Keep in mind, big B is a formula I come up with based on the situation I'm faced. So I'm looking at this, well, I got triangles. I've got a right triangle, which I can find the area of by base times height divided by 2. So I've got base times height divided by 2. My base and height are separated. Well, I shouldn't say separated. They're perpendicular to each other. What two numbers are perpendicular to each other in the triangle? In the triangle, the two numbers perpendicular are 3 and 4. So base times height, 3 times 4 divided by 2. It is actually 6. That is big B, the area of my base of this particular shape. Please note that big B changes because the base shape will change throughout our studies, and we have to know the appropriate base formula to put in. Now, I have LA 72. I have one base, 6. There are 2 of them here. So that's why it's 2 times 6 as I go through this. Okay, now I'm fully aware that this process can be shortcutted. I just want to make sure that you recognize where all the numbers are actually coming from, because that allows you to understand when I do the shortcuts as well. And we're at 84 centimeters squared. Same thing. The process doesn't change. What's the lateral area of the hexagon? First of all, I need perimeter and I need height of my 2 bases. Do I have enough information for perimeter for the lateral area? Remember what I'm doing. Let me get some more stuff here. I have a big old rectangle that I'm separating out here and here. Gosh, I never do give enough time. Let's see if I can get away with this. This is my, oh, it did, my net, right? And the lateral area is this rectangle. So 6 times 11 gives me this. This is, I shouldn't say 11. 6 times 6. I don't know where 11 came from. 6 times 6 is 36. And then I have my height separation, which is 12, right there. So that's the lateral area that we're looking for. So on this rectangle, I got 6 times 6 times 12, and I get 432. Now, we just finished chapter 10. Like it or not, we know, or at least have access to, a formula for a hexagon with an apothem of 3 to the square root of 3. That's what they tell me. So they're shortcutting my work. I'm going to use 1/2 ANS. I'm going to get rid of this net because it's in the way of some other stuff. But as you're looking at that 1/2 ANS, recognize the other things that we're finding. If I can bring this back up. So I got A, they tell me, A is that's 3 to the square root of 3. I've got N, the number of sides, 6, and I have S, the side length, 6. Now, please keep in mind, what we are currently doing, we're finding area of the base. So I'm really talking about big B. But big B, the formula represents, in this case, the formula for a hexagon because it's a hexagonal prism. Okay, big B will change throughout all our problems because the shape of the base will change throughout all of the problems. So as I do this, I got that. 54 to the square root of 3, well, that's the exact answer, and I have 93.53. Now, please keep in mind, the exact answer is going to be used to help me find my surface area. If I was just asked to find, hey, what's the area of the base? I got, hey, it's 93.53, okay? And that's meters squared. But please be advised as we go through these. I only want to round once. That's why I'm going to use the exact answer. So I got my surface area, my pH, which is LA. I've noticed I got tricky. I'm forcing you to learn what LA actually represents. It's perimeter times height, and that's perimeter of the base times the height, the separation of the two bases. And 2 times B, big B being the area of whatever base I'm looking for at. And I go ahead and plug those in. I round once in my calculator, I should come up with 619.06. If I round continually, as I get answers, I will have rounding error, and we want to avoid rounding error. Now it's time. It's time to know what we know and make a determination if we've got questions or not. So let's get to our next problem. And realize, first of all, I'm going to give everybody the same base. In this particular one, we have 3 choices. And then the things that ain't bases are lateral faces. So I'm telling you the base is the 5x4, and there's 2 of them because the base is consistent all the way through the figure. Okay, so this is also the base 5x4. I first must find my perimeter of my base, P, the height, which is the separation of the 2 bases, and the area of the base, big B, itself. The fact that big B is a rectangle is kind of nice because it makes this one short. Go ahead, figure this one out. Pop in your numbers. Remember, this is the general formula of every time we do surface area. This is about surface area, the covering. If I were to paint a shape, this is the amount of paint I would need in square units. First, P, the perimeter of the base. And I highlighted the base. I got 5 plus 4 plus 5 plus 4. I know that other 5 plus 4 isn't there, but they are. Okay? We got to go all the way around. We got to start at a spot. We got to end in that same spot. So now, when I'm looking at this, I got 5 plus 4 plus 5 plus 4. That's 18. My big B is base times height. Now, remember, that's specific to the base itself. Base and height. I need 2 values and multiply 5 and 4. Happens to be 20. The separation of my 2 black bases that I outlined. How far are they apart? They happen to be 5 inches apart. So that's my height. I have just labeled all the numbers that I'm popping in. Okay? You've got to make sure you know where they're from and be comfortable enough to do it on your own. P in lateral area is the perimeter of big B, the base of your prism. H, the separation of the 2 bases, the distance the 2 bases are apart. Big B is the area of the base, and you tailor big B's formula specific to the shape we're working with, and you'll see what that means in this next one. But after we do that, we get your numbers, we're done. 130, no problem, right? And yeah, you know, back in the day, you found the area of all 6 pieces and you added them together and you got the same answer. See, you don't have to do it that way. The formula is faster. You can actually do it in your head in the formula quite quickly, okay? The more comfortable you are with it. Now, we're going to use the same formula for this next one. This next one's a triangular pyramid, okay? The triangle base, it's a right triangle. And actually, because it's a special type of triangle, some things are made easier for us. Do you see that's an isosceles, right? 2 sides, the legs are the same, and they're hanging together with that right angle. So now I got a 45, 45, 90 right triangle. Do you remember 45, 45, 90s? It's a shortcut. My 2 legs are 7. The hypotenuse is 7 to the square root of 2. Did I have to remember that to be successful here? No, you could use Pythagorean theorem again. But I have news for you. We learned this in 8.2. I'm reviewing it because guess what? It's on the final. We got to make sure we're ready for it. So we got 7 to the square root of 2. So my perimeter is taken care of. 7 plus 7 plus 7 to the square root of 2 is 14 plus 7 to the square root of 2. I will put that in my calculator. Now, my height, the separation of my two bases is 6. That's height. Perimeter is equal to 7 plus 7 plus 7 to the square root of 2. Area of my base, tailored special because this is a triangular prism. Has to be a triangle. 1/2 base times height. Base is equal to 1/2 base times height. Well, because it's 7 squared divided by 2, right? 1/2 base times height. 49 divided by 2. So now I'm off to the races because that's the stuff I've got. There's 2 of them. That's why the 2's there. I underlined that too because there's 2 bases I'm adding in. But are you okay with where I got all my numbers? Now here's the deal. As we finish up, I got this all in my calculator. Matter of fact, these extra dots are telling you that Bloom didn't write the whole thing down. I just still got it in my calculator. I'm going to add 49 to it, okay, because that's what happens there with 2 times 1/2 of 49. And then I get my final answer and I round it without rounding error, no problem. Okay, 192.4. Now what I want to do, I want to turn the page. I want to get you the first part of the notes for tomorrow, and then we're done. You're just going to copy things down, and then we're off. So go ahead, write those down. We'll make the explanation of those tomorrow. We're going to start with cylinders tomorrow. Because of that, your assignment I just handed out has been truncated a bit because we're going to do this over 2 days. Your assignment tonight is 1 through 6, 10 through 14. Make sure you recognize that when you come across pentagons, hexagons, octagons, we're still using 1/2 ANS. We're still doing the central angle stuff, okay? It's not changed. It's still the same stuff from chapter 10, okay? So be advised. Number 1 might be kind of tough, but they're all not that tough. Just should have put probably that one on the later part of the page. The rest of them are pretty easily doable, okay? Now, if you have questions, if you have concerns, if you have calculator issues, make sure you come to class with those and we'll talk about them. Have a great day.